A great day. So, we are going to do a pendulum lab through pivot, and you guys are going to be testing the relationship between how long it takes our pendulum, so this guy right here, to make one back and forth swing with the length of the pendulum, the mass at the end of the pendulum, and at what angle it is released. So what we are going to do is we're going to walk through real quick just how we are going to collect those different data points. So the first thing you're going to test is the mass, okay? So when you guys come down here, you're going to click change. You want to select mass to be your independent variable. You're going to notice that most of your length and release angles go gray. That's a-okay. Just pick whichever ones are available to you, okay? So just pick whichever white ones, doesn't matter. Your mass, this is going to be the variable that we're changing. So we're going to see how the mass affects the period of our pendulum, or how long it takes to make one back and forth swing. So we'll click whatever mass we want to test first, and then click load. So then now we have a pendulum with a mass of 66.8 grams, okay? When you guys are ready to record, what you're going to want to do is you are going to want to use the stopwatch function. So go ahead and click on that. That way you can time how long it takes that pendulum to make one back and forth motion. So what's kind of tricky here is when you press play, the pendulum doesn't start moving right away, okay? You want to wait until that pendulum starts moving before you start recording. So it might be easiest to kind of move this box down here to set it right before it starts moving. And then you can click this to reset that stopwatch. And then if you want, you can just press this arrow to go frame by frame so you know you're not overshooting the time of the swing, okay? You can also use the toggle bar down here to make it go one forward swing and wait for it to come all the way back. And once it hits back where it started, we completed one period. So again, a period is one back and forth swing. So now we can see our time for that one back and forth swing with a mass of 66.8 grams is going to be 1.37 seconds, okay? And that is going to be what you want to record in that data table. Okay? To then get a second point, you'll just come back down here to change, pick a different mass, and then always remember to click load again. That'll restart your simulation. You'll need to restart your stopwatch, and you're going to follow the same procedure. You want to find the time that it takes for it to go one back and forth motion. So find right before where it starts to swing, reset your stopwatch, and then time how many seconds it takes to go forward and backward one time. And again, that's going to be what you guys put in your data table. Okay? You guys have gotten 5 data points for your mass. Now we can go ahead and see how our release angle affects the time for one back and forth swing or our period. So we'll come back down here to change. Unclick the mass as our independent variable, and now make the release angle our independent. So now we can see a lot of our lengths and a lot of our masses have gone gray. So we're just going to pick whichever ones are available to us. Does not matter because we are not changing those. And you can pick whatever release angle you want to measure at. Oops. All right, so let's say I want to do release angle C. I'll click load. Okay. So here, since we're looking at the release angle, what we're going to want to use or define is at what angle our pendulum is being released at. So if we come up here, we can click on our tools, click on our protractor, and then this guy will pop up. And then we can read what angle is this pendulum being released at. And we can see it's about like 3.5 degrees. So that then we would record as our release angle for this trial, about 3.5 degrees. We're going to follow the same process that we did with our mass, with our timing. So we'll click on our stopwatch, reset that, and we're going to want to find the at what time our pendulum is released, and that is going to be the time that we're going to start recording, okay? Once we start recording, we're going to do the same thing. Find the amount of time that it takes to make one back and forth motion, and then how long it takes to get back to that starting point, and record this time then for a period when we have an angle of 3.5 degrees. Okay. Just like with our masses, you guys are going to test it at different angles. So between each trial, just hit change and select a different angle to then collect your data at. Okay. Just make sure you guys are recording the release angle you are using. So what angle is your pendulum being dropped from? We can see this one is about 10 degrees. And then also, how long does it take for that pendulum to do one back and forth swing at that release angle? Alrighty, the last thing we are going to test is the length of our string. So what we're going to do then is click change, unclick the release angle as your independent, and make sure you select length as your independent variable, because now that is the one that we are controlling. Select whatever release angle and masses are available, again, because we won't be changing those. And you're going to pick 7 different lengths from which to measure the period from. So if we do number 4, remember, make sure you click load. From here, we don't care about the protractor so much, so we can get rid of that. What we do care about is our the length of our string. So this, try and be as accurate as possible. It's going to be a little tricky since it's at an angle. You might want to move your video until the angle is, or that string is perfectly straight, and then record what the length of your string is. Okay, so here it looks like we are about 34 centimeters. Okay, so see where the bottom of that string hits the ruler. Okay. All right, then we're going to follow the same process as with our mass and our release angle. Okay, so we're going to take it back to right before it gets released, reset our stopwatch, and then find the time that it takes for one back and forth swing at this length of our pendulum. Okay. So here we can see at about 34 centimeters, the period or the time for one back and forth swing is about 1.1958 seconds. Okay. We're going to follow that same process with 7 other lengths. So each time, just click change, select a different length, click load, and then find what length that pendulum is at, and then how long it takes for one back and forth swing at that length. Okay. If you guys have any questions as you're working, please let me know, especially with the data collection and pivot, because then once you get your data, you'll be able to graph that, see if you have a relationship, and if you do, what relationship is present, and linearize if necessary. Okay. So let me know if you guys have any questions, and I'll be happy to help.